promised me he will watch the recording today. He promised me. This time, if he doesn't do it, I'll need to resort to heavier punishments. Okay, all right. Oh, wait. Okay, all right. So moving on, I think there's only one more example that I think I need to show you guys. This one. So far, you guys have only been dealing with position and velocity only, right? But remember the diagram I drew you guys is x, v, and a. So it has acceleration as well. Acceleration is essentially the rate of change of velocity. Okay, so remember the xva thing, xva, right? In this case, we're given x, but then they ask you for the initial position, velocity, and acceleration, and hence describe its motion. Right? Describe its motion. This is the new part here. All right. So they ask us for like everything. So basically both velocity and acceleration. So you need to find velocity, which is deriving x, and then acceleration, which is deriving velocity. So let's do those ones first. V is dx over dt, which is going to be 3t squared minus 12t. Okay, and then acceleration is deriving velocity. So note that you're deriving velocity to get acceleration. dv over dt. So this would be 6t minus 12. So far, you guys are only doing mostly polynomial equations. Wait until unit 3, you will have exponential, trigonometric, and logarithmic equations to derive. That's going to be a lot more fun. But for now, it's just simple polynomial, right? Bring the power down, drop the power by 1, yada yada. Okay, all right. So that's velocity and acceleration. Now they ask us for the initial position, velocity, acceleration. Essentially, they're asking us for x of 0, v of 0, and a of 0. Okay, just sub the time 0 into each of the xva equations. These are all polynomial equations, which means that when you sub 0 in, you just ignore, for example, t, you just ignore anything that has t in it. So the answer would be 5. And then the velocity at 0 would be 0, 0. So the answer is just 0. And then acceleration at 0 would be, take that out, would be minus 12. Let's put in the units. So that'll be centimeters. Velocity is centimeters per second. And acceleration is centimeters per second squared. Okay. So that's the initial position, velocity, and acceleration. Now, describe its motion. So, first part, describing the motion. What does that mean? So, let's say, Charlie, give me a statement around that value there.
Like, its initial position is 5 centimeters to the right of O.
Yep. It starts at 5 centimeters to the right of O. Is it O? Yes. To the right of O. Okay, very good. Sarah, give me an interpretation for this one, like the description for this one, an observation.
It's stationary.
Initially stationary. Okay, or it starts. Whoops, change that up. Or another way of saying it is it starts at rest. Okay, so we're going to add more into this statement here. So this one means it starts at rest. Yeah, you see this phrase quite a bit. It starts at rest. And then it starts at rest at 5 centimeters to the right of O. Now the last one, Charlie, how do you interpret this statement here? Well, this value here.
I don't think it has an initial acceleration of negative 12 centimeters.
Yeah, that's it. That's the only thing that you can say. It starts at rest at 5 centimeters to the right of O and has initial acceleration of negative 12 centimeters per second squared. I think that's all you can say. You can't really say much about acceleration. Okay, so Okay, let's see. Acceleration of Okay, so yeah, they said that it starts. They say it's instantaneously at rest. It's just essentially it starts at rest. That's fine. Yeah. Okay, now if the initial acceleration is negative 12 centimeters per second, is it moving to the left first or to the right first?
To the left.
To the left because of the negative. Okay, you guys get this idea. It's not too bad. Now, question B. Find the times when it is instantaneously at rest and determine the position and acceleration at those times. So what are they asking us to do here in question B?
Isn't that just like when velocity is 0, right?
Yep. So sub velocity equals to 0 and then find. What are we finding here? Sarah? Sorry?
Initial velocity.
Not quite. You're finding the yes. Find t. Okay, and then determine its position and acceleration at those times. So what are we doing in terms of like the mathematical equations?
Sub t into x and a.
Yeah, that's right. That's it. That's all you guys need to do here. Okay, so b equals to 0. So 0 equals to 3t squared minus 12t. And when you see polynomials, always try to factorize it. So 3t, t minus 4, which means t equals to 0 or t equals to 4. And then sub t into x and a, so we'll find the x of 0. Well, when t equals to 0, we already found all the values, right? Before x and a. So now we just need to find x of 4 and a of 4. That's it. So x of 4 would be, what's the x equation? 4 cubed minus 6 times 4 squared and then plus 5. Okay, and the acceleration equation is 6t minus 12, so it'll be 6 times 4 minus 12. So that will be 24 minus 12 is 12 centimeters per second squared. And then this one would be, I'll take the 4 squared out. So 4 squared, that will be 4 minus 6 and then plus 5. That will be 16 times negative 2 plus 5. So that's negative 32 plus 5 is negative 27. Okay, all right. Therefore, it is at rest instantaneously. Do you guys know what instantaneously mean? This term, really big
Why'd you
word.
put 4 into A?
Oh, because they asked you for the determine the position and acceleration at those times. So at the 2 times that we found, which is 0 and 4. Right, there are 2 times.
You also have to do the same thing for
0.
yeah.
Yes, we technically do have to, but we already did that over here. Yeah. So we'll just use the values from here. So it is instantaneously at rest. Right, at rest when. So the first answer is t equals to 0, x equals to, I think, what was it? 5, and acceleration is 5 centimeters, and then acceleration is negative 12 centimeters per second squared. And then also at t equals to 4, and then the x value is negative 27 centimeters. That's the position. Acceleration is 12 centimeters per second squared. That's the final conclusion for part B. Yeah, that's it. Okay, so for this kinematics one is essentially understanding when to sub something equals to 0, and then when to find the time, and then when to sub the t value, which is the time, into which equation to solve. That's it. You just have like maximum 3 equations, right? The x equation, the v equation, and the a for acceleration equation. And then you just gotta find the, so sometimes you sub v equals to 0, and then sometimes they might ask you some harder ones. For example, let's say if they ask you to find the time when it returns to the initial position, what do you sub equals to 0? time when, okay, this is an advanced one, yeah? So just to check, find, let's say if you see something like this, find time when it returns to the origin, for example, returns to the origin, or when it passes the origin. It passes by the origin. What are we finding here?
I don't know, because O isn't a number though.
O isn't a number, but the position is always relative to the origin. So when it passes by the origin, what's the position? How do you interpret passing by the origin? This means the position is 0. So essentially you sub, so this one is like saying sub x equals to 0 and then find t. Okay, so you see most of these kinematics questions, you need to, as long as you understand the questions, you just put 0 into the right value most of the time, and then you find the other variable and and that's it. Right? It's just sub in what, where, and find what. Okay, so the only way for you to get better at this question is to do more of these questions. That's literally the only way. So because of that, we're going to do more of these questions, starting from question 3. Do as many as we can, and then if we have time, we'll cycle back to do some revision today. So once again, I will start working through this question straight away, and I'll go and check on you guys afterwards. So look at the question if you don't want any spoilers. Otherwise, have a look if you need any help.
What's the rate of change of position? Just like centimeters per second?
Which means it is the... Yes, it is the velocity. You can be more confident with your answer. Okay. Did everyone get this one? Yeah? Okay. Sarah?
If they, is the reason you have like negative 12, square root of 12 is because of their restriction?
That's correct, because of the restriction here. Okay, if you're done, move on to, this is going to be interesting. Let's try question, hang on. Let's try question 4. It's a complex, unfamiliar question. There is no equation. So question 4 is essentially asking you to interpret this based on your understanding of of all the concepts that we've gone through so far. Right? There's no equation for you to, or at least not at the beginning, right? There's no equation at the beginning for you to do A, B, C, and D.
Is it when t equals 2 for the first question?
Yes.
Does r equal 0?
Yes, I would be 0, yes.
And then how do you find p and q then?
So hint for you is use the turning point and use the equation of the line of symmetry formula. Would you get that? Yeah. Or essentially you can just substitute in 2 points. Pick 2 points because you're finding Q and P and Q, right? Which is a simultaneous equation question. So you choose 2 points. The hint is you choose the turning point 2, 8, right? And then you have to choose another point because you already used the point 0 to find R. So you have to choose the other point, which is 4, 0.
Okay, so
And then you can find P and Q, solve simultaneously. Are you guys doing E at the moment?
I'm lost quite. I'm very confused.
Which part are you up to now?
Well, I'm really confused.
For question E?
Yeah, because first I have 8 equals 4p plus 2q.
Mm-hmm.
But then where'd you get 16 from? Because,
Times it by 2. I'm just changing the equation so I
but
can...
isn't it 4 0, so it's 0 equals 16p plus 4q?
Yes, that is this one here.
Yeah.
So there are 2 equations. But to solve them, you need to either use elimination, which is what I did in this case, or substitution. So in this case, I use elimination. So essentially, I see this 2q, I want to turn that into 4q. So I can subtract the 2 equations, like so. Right? So this is equation 2, and this is subtract equation 1. Right? And then the 4q subtract 4q will cancel out, and then you have only p left, and you can solve for
Well,
p.
why'd you, like... But you can't times it by that's changing the equation.
It's not changing it because I times everything by 2. So you see, 8 goes to 16, 4p goes to 8p, and 2q goes to 4q. So it's still the same equation. Right? So that's why the substitute 2a, that first box there on the left, that one is the very first equation that you get when you sub 2a, and then you got to change that up in order to do elimination. So this is back to the simultaneous equation solving in unit 1. So this is how they throw in like topics from unit 1 to make the questions harder essentially. Right, Sarah, any question?
How did you get like 4p and 2q?
4p and 2q. You're just substituting the 0.28 into the main equation, which is this one here. Right? So 28 means t equals to 28 means time is equals to 2. Or to zoom in. So this is the t value, right? And then this is the x value, right? So when time equals to 2, it's like saying p times 2 squared. And then plus q times 2. Right? And then r is 0. And then the x value is 8. Okay. All good, Charlie? Okay, -4. Alright, good. Okay, well, if you finish with that, Charlie, move on to question. Let's see. Question 5. So, question 5. Okay, Sarah, which question are you up to?
Still in.
E? Okay, yeah, finish that and then get started on question 5.
Wouldn't it be just instantaneous? Because the answer for the question is that it's instantaneously at rest at 5 centimeters. So then for question B, wouldn't it just be instantaneously at rest at 5 centimeters?
So question A tells you the initial position is 5 centimeters.
Yeah, but when they answer the question, it says it's instantaneously at rest at 5 centimeters. They've used it the same two terms.
Instantaneously at rest at 5 centimeters.
Yeah, when they describe the motion, they say initially the particle is instantaneously at rest at 5 centimeters, and then it asks when it's instantaneously at rest. So wouldn't it be instantaneously at rest at 5 centimeters?
Oh, I'm a bit confused. You're talking about 5A, right?
Yeah,
Or
but
5...
then in the example that's the exact same as this, and that we did before, and we said it was instantaneously at rest at 5 centimeters. It says when is it instantaneously at rest, so isn't it at 5 centimeters?
This one is a bit different though. Oh, yeah. Okay. Yeah, so that's one of the points where it's instantaneously at rest. There would be another point. Yeah, there'll be 2 points. But yes, that's 1 point because it is instant. You're right. It is instantaneously at rest. Initially at 5 centimeters, yes. But there should be another one. The question, Sarah? So after this one, we'll do a slightly different question from the example. That'll be question 8. Okay. Did you get that, Charlie? Okay, good. Perfect answer. No issue?
No.
Okay. Question 8 is next. Any questions, Sarah?
How do you like know what t equals 0? Like the rest is if you don't have this stuff.
Because we calculated that from part A. Oh, wait, not that one, this one. Alright, so part A is already half of the answer because that's when t equals 0, right? So that's x0 and a0.
If the acceleration is like the derivative of the velocity,
Yep.
then how do I find the derivative of velocity if it just makes like a equal a whole number?
That's fine. That's fine. It could be a constant acceleration. So if a equals a whole number, it just means that acceleration is constantly at that value. It doesn't change over time. Let's say imagine if you step on the gas in your car and you don't change the pressure of the gas, then it's constantly accelerating. So the velocity changes, right? It increases, right? But then the acceleration doesn't change. But if you keep on slowly pressing more and more and more into the gas, then the acceleration increases over time. Or let's say you're driving and then you slowly release the gas, like bit by bit, then the acceleration is decreasing over time. Kind of. Yeah, it's lowering down, yeah. So yeah, so acceleration equals to constant number, it just means it's like a constant acceleration over time. Hi, Sarah, any question for me from question 5?
How do you know whether or not you put squared in the units?
Acceleration is always per centimeters per second squared, so it's always per time squared. Yeah, so this is like a physics thing.
But do you not have to do that for when you work out a during the problem?
You're correct. Technically, I should have put in over s squared. Yes, you're right. Yeah, that should be everywhere. Yeah. So acceleration is always per second squared. Okay, so Sarah, quickly wrap that up and try question 8. Okay, so if you are confident, I want you to move on to question 8 first. So question 8 is a more encompassing question. It has a lot more parts in this. Let's try this one out. It even has a distance travel, which means you have to draw the time travel graph for question 8.
This question doesn't make sense.
Which one?
Because if it's the distance traveled in the first 5 seconds, but when t equals 5, x equals 0.
It can be. Yeah.
Wait, just give me a sec. I don't want to do that in my head. I don't want to do it in my head.
This is not a calculator question, I'm pretty sure. But alright, you cheat for this one. As long as you get the right answer, it's about the concept is more important right now. Any questions, Sarah?
What was the acceleration?
2, when you derive the velocity, right? The -7 is gone, 2t becomes 2. So 2 means it's constantly accelerating at 2 centimeters per second squared. So it's like the velocity is changing constantly. So it will be like, it starts at, how much? It starts at -7. So it increases it by 2, it will be -7, -5, -3, -1. And then, yeah, it's just constantly increasing at the same value every second. You done with question 8? Okay. Good. The next one will be question 9. So take a break first. When I'm done, then we can get started.
So much math, Corey.
I know. It's you guys. You will have done enough math for today.
Makes
By the
me
end
feel
of the lesson.
sick.
But you're doing well. You guys are doing well. We're doing a lot of questions. Okay, so note that after today, you guys will have learned basically all the concepts in Unit 2. So I think next week we'll probably start on doing some revisions.
So s equals 0 at O, right?
Correct.
Okay. So when I take out like the t from it, can I just like get rid of it altogether for a? Because it'll be like t times t squared minus 3t plus 2.
And that whole thing is equal to 0. So then no factor law. So the t could also be 0. So the particle actually starts at O. That's why you need to know, you need to sub it out and then no factor law. So the first t that is factored out, that one can also be 0. Hey, Sarah, any question for me? Okay, finish that, and then which question are you on now?
The like substituting x t into x.
Okay, for D, right? Yep, okay, finish that, and then you can start on question 9. Actually, Sarah, let me know when you're finished. I will move you guys onto a different question. Not question 9. So yeah, I don't need to.
I just started calling.
Sorry, child. You can complete that. That will be for homework anyway. So you can just continue on that later. But I'll show you guys a complex unfamiliar question instead. So just absorbing, no working.
Average.
Done, Sarah? Okay, sorry, Charlie, I'll pause you there. Have a look at this one. Let's discuss this question. It will be the last question for today. Okay? Last question for today. No need to write this down. I don't expect you guys to do this one yet. It might come in later in one of our revision quizzes that you guys will have to do. But question 15. Let's read this one. Two particles are moving along a straight path. Now, instantly, you know this is tough when you see two particles. So far, you've only been dealing with one. Now you're dealing with two particles. So the positions x1 and x2 are given by two equations. Alright. Okay, so x1 equals t plus 2, and then x2 equals to t squared minus 2t minus 2. Find the time when the particles are at the same position. How do we do this?
Make them equal each other.
Yes, that is correct. The positions are the same, so equate the position, right? Equate their position. Okay, so essentially what you're doing is just going, oh yeah, the position x1 must be equals to position x2, and then you sub the values in. So t equals to t plus 2 equals to t squared minus 2t minus 2. Put everything onto one side, t squared minus 3t minus 4. So hang on, a, c, b would be -4 and -3. Wait, does that work? Oh yes. Wait, does it?
No,
No, it doesn't.
1 and -4.
Oh yeah, -1, -4. Yeah, -4 and +1.
Yeah.
Right, so times the -4 and add
Can
to.
you do +1, -4, or does it like not matter?
It's positive, doesn't matter. As long as you get t plus 1 and then t minus 4, right, you would get the answer. Okay, so find the time, and then so you're assuming at any time t second, you're assuming t must be more than 0. So it's so you would get t equals to 4 or t equals -1, and this one is rejected because t time is normally always more than 0. So answer the time when the particles are at the same position when t equals to 4 unit is seconds. Yes. Okay, all right. So not too bad, right? Complex, unfamiliar question. It's just a little bit different, but it's actually not too bad. Now, question B. Find the time when the particles are moving with the same velocity. How do we do this?
Find the derivative of both equations.
And then?
Make them equal each other.
Yes, that's right. Okay, Charlie, you should probably just sit the exam right now. You're able to do these kind of questions. Sarah, does it make sense?
Yeah, just how do you? Is it like always the negative value will be rejected? Or?
For time, most of the time, yes. For time. Remember, position can be negative. It just means it's to the left, right? And then velocity can be negative. It means it's traveling to the left. Acceleration can also be negative. Only time can't be negative. Yeah, it's normally start from time 0, from the beginning, right? Initially it's time 0, so you can't go negative for time. Okay, so yeah, so I'll do question B. So essentially the velocity v1 would be differentiate x1, that would just be constant 1. Is it centimeters? Yes, centimeters per second. And then v2 would be 2t minus 2. All right, same velocity, so just equate v1 equals v2 and find out when the time is. So that'll be 1 equals 2t minus 2, and then t would be 3/2. Yeah, so that's the time when the particles are moving with the same velocity. All right, so same, just write a conclusion. Same velocity when t equals to 1.5 seconds. Okay. Make sense? All right, Sarah? Make sense? Yeah. What's your confidence on this chapter, 19F? Out of 10?
Like an 8 maybe.
8 out of 10? Sarah? 5 or 6? Okay. I will send you guys more homework anyway, so it'll be good for revision. And then we'll start doing revision next week. There are a few questions in chapter 20 that potentially will be these ones. So essentially imagine, instead of differentiating straight away these questions, you might get a product rule that you might need to apply the product rule in order to derive it to get the velocity, and then you work out the rest. Yeah. So chapter 20 is just essentially the same kind of application questions, but they just throw in either product rule, chain rule, or the the quotient rule.
Okay.
But yeah, that's about it. Not too bad.